I'll go back to the study because that's what I was talking about. So basically, you can click on the study, follow along, and you can see there's a lot of noise here. Obviously, I'll spawn somewhere else. So we can see, like, this guy has a hypothesis, right, in the background, right? This guy went to medical school, right? He's a what is he? Who authored this study? I think it's a few people. It might be a few people. I think the main guy was just one dude. He was at the bottom, I think. He did the conclusion. Yeah, those are some references. They have acknowledgements. Let me see. So they have some editors. They give me acknowledgements. The authors conclude contributions. So this is actually, you see the full text. Usually you don't get to see the full text on PubMed. It's usually behind a paywall, but it's a rare one. You can actually see, like, you can see if they declare competing interest. Obviously, you can never believe what they declare. You have to look that up independently. And there's databases you can search to see if they actually have competing interests that they didn't declare. I linked some of those in a bunch of other streams, but that's kind of, maybe we can go into that after.
Is this a hotel?
It's not clear, not really clear who exactly the authors are, I don't think. I don't think it's all these guys that I listed there. It could be, but unlikely, I would think. Oh, here, author information there. So this study, like, and this is why these studies are not common. This study was done in Brazil. And obviously Jose D. Botticelli, that's obviously the main guy conducting this study. And these are, they could be graduate students, you don't really know. They could be co-workers of his. They're probably graduate students or teaching assistants or something. Maybe some students that are helping him. You don't really know unless you do some more research, but obviously, he's trying to prove that Coke is bad for you. So he conducted a good experiment based on a scientific method, right? That's the hypothesis. It's probably not good for you, right? So what he has is 3 groups. He has 45 rats. He splits them into 3 groups, 15 each. So they're even groups. Obviously, he didn't mess up. We got to make sure they didn't mess up. We got to make sure they followed the scientific method properly. So one group is water, right? That's control, right? He did that right. He did that correctly. They have light Coca-Cola, that's a variable. Regular Coca-Cola, that's another variable. So you got 2 variables, you got a control or placebo, whatever you want to call it. It's a proper study. The results should be, replicable if you do the same experiment at home. Assuming he didn't mess up further down in the methods. But we'll go over that. Now the results, this is what Doug in the Bag he asked about first, so we'll go over that. And it says, based on the results, it can be concluded that daily ingestion of a large amount of fructose-rich soft drink resulted in unfavorable alterations to the lipid profile of the rats. So that's the conclusion, written by the author, written by this author who teaches at Sao Paulo State University in the Department of Physical Education. He probably went to medical school, right? He probably has some, does he have a PhD? Probably does. Let's see if it shows up here if I click on his name. I mean, we could probably assume he has a PhD. I mean, he's teaching at a university, like. He's probably gonna have, it doesn't matter, but what matters is he went to medical school. He went to modern medical school where they teach you that what? What do they teach you? They teach you that LDL cholesterol, right, is bad for you, and HDL cholesterol is good for you. That's what they teach you. They teach you that triglycerides being, increasing, that's bad for you, right? This is what he learned in medical school. And that's what happened in this study, right? So the conclusion, it's not necessarily inaccurate. What's inaccurate is that based on what he learned in medical school, he thinks it resulted in unfavorable alterations to the lipid profile of rats. When the actual conclusion, if he had a better biology teacher, paid more attention or something, I don't know exactly. I don't know what program, I don't know what school he went to, where he got his degrees. He's teaching in Brazil, but that obviously he probably went to college in America. Most people do. He might have went to one of the colleges in Brazil, we don't know, but either way, they're teaching generally the same stuff. And what he learned, obviously, I just explained, and that's what the results showed. But the results showed something way more significant that he didn't put in the conclusion. And we'll scroll down and we'll put that out there right now so it's obvious. And it's actually on a graph. They actually graphed this, so they did a pretty good job. Like with this study, it's obviously a very simple study. You could do this at home, but there we linked the graphs. You can pull that up. You could just scroll down the document if you're already there, and you see from Figure 1, you see the food intake throughout the length of the study. It looks like it's about roughly 8 weeks, 7.5 weeks. All the rats died pretty much at 8 weeks. The rats don't live. That's normal for rats. They're not usually living more than 2 months. That's why they use them in these experiments, because you see what happens over the entire lifespan. So this is what you do before you do human trials in general. They test stuff on rats. So now you can see from this, the liquid intake, right? It's a lot more for the group eating Coca-Cola. That's the I group in the graph, or that's the whatever. It's the group with the bigger graphs, basically. The food intake, it's the far right. The food intake for the rats drinking that had access to Coca-Cola out of their dropper, like they could drink unlimited, basically, of whatever's in their dropper: water, Diet Coke, or Coke. And the ones that were drinking Coke, they ate a lot less of what's called rat chow. It's what, if you go to a store, you got a hamster, you buy like the standard food for it. That's what it is. It's garbage. It's got a whole bunch of garbage and a whole bunch of toxins. It's low quality food. It's not human grade food. Like it'll probably say that on the label. It's not human grade because they don't want you to eat it, get sick, and sue them. Because it's such low quality, expired stuff that wasn't fit for the human food supply. So they made it into rat food. If it's super low quality, if it's better quality, they make it into rat food. If it's worse than that, they make it into dog food. If it's worse than that, obviously, I don't know what goes below that, but rats are definitely at the bottom. They get the worst food. So the rats drink Coke. Didn't eat as much food. The other two, Diet Coke, water, roughly the same, right? Not a big difference. The liquid intake, obviously a lot more per day. This is per day, these graphs. It's not throughout the course of the experiment. This is every single day, the average throughout the course of the experiment. 2 months, their entire lifespan. They're drinking almost twice as much liquid, right? Every single day. I think it's actually more than that, but I think it shows about twice as much. This is in, what is this in? The graph in. It's grams per 100 grams, so they're doing it based on their weight, but they're doing liquid intake in grams per 100 grams. So they drink way more liquid, right? And if you watch the show, basically liquid, or if you watch like my channel or whatever, liquid is not good for your metabolism. Like your body has to use a lot of energy to detoxify it. It's gonna generally slow your metabolism down. It's gonna cause some health problems drinking too much liquid. But so these rats drink a lot of liquid. The ones drinking Coke, these other ones about the same, right? Diet Coke, water, roughly the same. Now caloric intake, Diet Coke, water group, the same, right? Roughly the same. Throughout the course of the experiment, the ones drinking water, Diet Coke, eating the same amount of food. The ones that had access to Coke, right, though, there's a big anomaly here. So what does that mean? These rats were eating what? It looks like roughly 1,500 calories a day, right? Well, these rats that have access to Coke, they're eating about 7,000 calories a day, like throughout the course of the experiment. So you would think, okay, it's about 4 times as much when you go to the actual data set. So like you can make the equivalent to humans. Like obviously this is already adjusted. It's kcals per 100 grams, but generally like it's basically like you have someone eating 2,000 calories a day, right? They drink water, they eat normal food, and you have someone they're drinking Coke and the same normal food, but they're eating less than normal food, and they're drinking like they're getting 8,000 calories a day. So the average human, right? They think, okay, this person's gonna be really fat, right? They're gonna have diabetes pretty soon, right? Drinking Coke every day in these quantities. The whole lifespan of a rat, like what actually happened? So to see what actually happened, you don't see that in the conclusion, right? You see it in the data set. So you have to go to the data set because you got to realize this guy, he might not know much about biology. He might not know how to interpret his own data set. Like that's common. That's very common. That's extremely common. That's pretty much the norm in any PubMed study that you see. Like the peer reviewers messed up and they didn't even have a control or something. And it somehow got published and it got peer reviewed somehow, or the conclusions, the data set was just not interpreted properly because the person didn't understand biology, or he didn't understand something. There's a lot of things. It's not simple stuff. Like this complex stuff. There's a lot of different things. Like you gotta understand LDL cholesterol, HDL cholesterol. You gotta understand triglycerides. You gotta understand why they go up. You gotta understand what is in rat chow, why. You gotta understand why LDL cholesterol goes up. You gotta be aware of what raises LDL cholesterol in humans, in rats, in animal studies. What does that? You gotta be aware of that. And like this guy probably didn't know, right? He just figured sugar's bad. Oh look, their LDL went up, their triglycerides went up. I proved it. Sugar's bad. He's probably drinking water right now. He's not thinking about it. But you look at this graph, they're eating 4 times as many calories, and you look at the results, right? There was no significant difference in the evolution of body weight among the 3 groups of animals during the experiment. So throughout the entire course of the experiment, and I'll link this from the actual results. When you go to the full text, you just scroll down, and that's there. You're talking about figure 22. That's what I just posted. It's figure F1. That's what it's called, but that's figure 22. And you see, they can't conclude any difference in weight. So where does extra calories go then? If they didn't show up throughout the course of an entire rat's lifespan, yet they're eating 4 times as many calories as these other rats, and there's no significant difference in body weight. They can't conclude any difference. So what happened, right? Where did the extra 6,000 calories worth of energy go? And obviously, you gotta look at the rest of the results to figure out what happened, right? And what happened is, like, you don't really, not all this stuff is measured, obviously, because they're not testing for a whole lot. This was not an expensive study. Like, they did some blood samples, but they didn't obviously test a whole lot of things. They tested, obviously, glucose levels. They didn't find a difference there. Like, these rats, throughout a lifespan, eating 4 times as many calories of mainly Coca-Cola, compared to rats drinking water, they didn't get diabetes. There was no instance of that. The only thing they could really conclude was negative was LDL went up, HDL went down, and triglycerides went up. But that's actually positive, and I'll explain why it's positive in a minute. I'm just going to see if they found anything else. But basically, what you can assume and what happens when you overeat in human experiments, you don't gain weight, but you expend the energy as heat. And basically, what that means is the metabolic rate of the person is increasing. So your body is using all this extra energy to basically run your metabolism at a higher rate until the energy runs out, until your liver runs out of glycogen. Then your metabolism has to adjust downwards because there's a lack of energy. So these rats, they didn't measure it. They measured the body weight. They measured the blood glucose level. They didn't find them getting diabetes. They didn't find them getting fatter. They're actually, let me see which group was the, R is the regular. There's actually, the water group weighed more than the Coke group. The Diet Coke group weighed the less, and this kind of makes sense with what I'll explain about cholesterol in a minute. But the ones drinking just water, they fatter than the ones drinking Coke throughout the experiment. So, like, what do you think happened there if they actually measured their body composition? Like, the ones drinking all the extra Coke, they're gonna have way better bone density. They're gonna have way denser muscle mass. They're gonna be way stronger. They're gonna weigh the same. But this one drinking water, these are skinny fat rats, right? They're just skinny fat. Same with the ones drinking Diet Coke, they're actually sick. They weigh the least amount. They had the lowest LDL cholesterol, the lowest triglycerides. The ones drinking Diet Coke, they had better results in cholesterol and triglycerides than the rats drinking just water. And that kind of goes into what I'm going to talk about next, is that everyone kind of knows there's toxins in Diet Coke, like aspartame, some of these sugars, sweetener stuff that's been studied. They're not epic toxins, but they cause damage. When they've been studied independently, they cause a certain amount of damage. They're linked to like cancers and various things. They're not causing them at a very high frequency, but these are things generally people realize, like diet soda has got garbage in it, right? Everyone knows this. Everyone thinks water is healthier than diet soda. So then why does LDL go down the most in this study from the rats drinking the diet soda? The water, if it was the healthiest, right, they should have the lowest LDL, right? But they don't. They have higher LDL cholesterol. They have higher triglycerides than the rats drinking the Diet Coke, right? And basically, now you have to understand, LDL cholesterol, it's been studied, and we know how to lower it. That's why we have so many different kinds of statins. And the way you lower LDL cholesterol is you ingest a toxin, anything that's toxic to your liver, any toxin lowers LDL cholesterol, anything. Vegetable oil does it, and vegetable oil has been studied independently. It's carcinogenic. Like, there's very well done studies, a whole bunch of them. You know, a lot of them are old. Like, some of them are recent. Like, there's epidemiology of different populations. Like France, like, there's paradoxes, right? Like, you can look this up on Wikipedia. There's the Israel paradox. And that's because they call it a paradox in nutrition because Israel has the lowest rate of saturated fat intake in the world. One of the lowest rates in the world. They have one of the highest intakes of unsaturated fat of vegetable oil. Basically, it's like soybean oil, canola oil, like all the vegetable oils that if you eat fried food and if you buy it anywhere, it's going to be fried in one of these oils. They have the highest intake of this oil in the world in Israel. And you would think, okay, if this stuff is healthy for you, they're not gonna have as much heart disease, right? They're not gonna have as much cancer, but it's a paradox because they have the highest rates of heart disease, of cancer, of a lot of these diseases in the world. And you know that it's not genetic because this has been studied too. And Israel, obviously, it's a very recent country. You know, it's only been a country since the end of World War II. And then you had a lot of immigration to Israel from different countries. Different people that were Jewish, that lived in different areas, or for every reason wanted to move to Israel. You had a lot of people from a whole bunch of different countries move there in a very short time period. So obviously, someone thought this is a good idea to study what happens to these people. You have all these different genetics, right? All these different, they pretty much you give them genetic tests. They don't mean anything because your genes are expressed based on your environment. So, two people move to the same place, they stay there a generation, they're going to have the same exact genes expressed as another human. If they go to another environment, it's going to be the same too. And this study, I'm going to find it actually because it's a really good study. Like, it's really smart people that decided to study this. It's what, like, epidemiology is supposed to be used for, but there's very few people do this, but but what these guys found while I look at the study, and here I think I found it already. This has been studied in a couple different diseases and a couple different there's a couple different articles about it now. Like, it's been a few different things, like a few different what do I want to call them? They're not necessarily studies because it's all epidemiology, but this has been studied, by a few different people by this time. Let me see what this one says. I think this is one of them. Let me make sure I just click the link. This is one of the studies, I'm pretty sure. I'll just read it. I'm pretty sure this is one of the ones I was thinking of. But they're basically looking for an association between immigration and increased prevalence of heart disease, basically, and mortality. So they're comparing the risk profile of heart disease patients, basically, or people that are dying of heart disease that are born in Israel, with those who immigrated to Israel from the Soviet Union, is what this study covers. There's a few of these looking at different populations, looking at cancer, looking at other diseases. This one is on heart disease. And basically they had data on, they're using 18 Israeli hospitals for a period of, I guess this was from a study, this was from another epidemiology like paper, basically, in the early 1990s. And they reported data, the data set they're using for this study, it's data on mortality after pretty much 8 years follow-up. So basically, they go in, they measure up. 8 years later, they look up their medical records, or they have them in again to get new records. They figure out if they're dead, what happened, how did their markers change after 8 years. That's what it means. And I guess this was studied by different people. These people are just analyzing the data now in this document I just linked. That's from PubMed. And what they found basically is it's like they're not finding a difference in age groups with people that just immigrated. And basically what they find in all of these studies is that after a generation of immigrating to Israel, they have the same exact risk of every single disease, the same exact mortality from every single disease as people that have lived in Israel that have completely different genes. Just after 1 or 2 generations, it's virtually identical. Doesn't matter where they came from. Doesn't matter what the disease is. And the reason why this is studied a lot in Israel is because it's generally a closed population. It's not easy to get in. It's not easy to get out. You know, the environment is very stable. You know, there's not a whole bunch of tourism. I mean, there is some, but like, you know, there's not a whole bunch of variables. It's a very small country. And basically, we'll put the conclusion, because the conclusion is accurate based on the data set. You can kind of see it from the results. I'll just paste the conclusion. You know, so they're saying that basically, you know, it can't be explained by traditional risk factors, which are generally blamed on genetics, on things like smoking. But they found that even smoking, these things that generally are thought to cause heart disease, you know, this thing has nothing to do, like, it doesn't show up in the data set. There's no link there. So it's something other than that that's unique to Israel's environment that causes these rates of diseases, you know, that are irrelevant of genetics, basically, within 1 generation of immigration. And there's a whole bunch of different studies about kind of different diseases where they're drawing from similar data sets. And so basically, what I was trying to say is, like, I was saying this is why vegetable oil is bad for you, because there's Israel paradox. There's also the French paradox. Obviously, if you've been to France, if you know anything about France, there's cheese everywhere, right? There's desserts everywhere. They're using butter in everything. There's croissants everywhere. It's saturated fat, capital of the world. They're not afraid, right? They're not using vegetable oils because it doesn't taste as good. You can't make a good croissant with vegetable oils. They know this in France. They only use butter. And if saturated fat was bad for you, right? If it increased heart disease, you'd expect to see that in France, right? This is not a new thing with the French. They've been eating cheese for a long time, right? But there's a thing called the French paradox. You can find this on Wikipedia too. It's called the French paradox, and they have one of the lowest rates of heart disease in the world, one of the highest rates of saturated fat intake in the world. So obviously, you know, something's off there, at least with vegetable oils and saturated fat, and it's the same with sugar. And what you can tell from this study is basically LDL cholesterol goes down in response to any toxin. Like, you can look up studies on any type of toxin, any poison. Like, doesn't matter if it's anthrax, it doesn't matter if it's vegetable oil, it doesn't matter if it's a statin, which is a very minor toxin, because that's how they can prescribe it your whole lifetime, and it only lowers LDL a little bit, because your liver can generally detoxify it. But what happens when your body's exposed to a toxin is your liver uses glycogen, and it produces LDL cholesterol. And, you know, if you study biology, testosterone, progesterone, all your hormones are produced in your liver from downstream from the production of LDL cholesterol, which requires stored glycogen in your liver, or your body doesn't produce it, and your cholesterol goes down. And generally, as you age, your cholesterol goes down, and your LDL cholesterol goes up if you eat enough food, but your HDL cholesterol, which is actually more beneficial, goes down. Or it's actually negative. Never mind, it's negative. It goes up. Your HDL goes up, and your LDL generally goes down as you age. And the reason why the rats drinking the Coke were able to elevate their LDL and reduce and elevate their triglycerides, basically, is because that all the extra sugar they were eating was allowing them to manufacture enough triglyceride and enough LDL cholesterol to basically deal with the toxins in the garbage rat food that they were eating, that they were voluntarily consuming less than the control and the rats drinking Diet Coke that had the same food but didn't have access to extra sugar. Like, they ate less of this food, but it's still toxic. And their liver can't detoxify it all. So what happens is your body produces LDL cholesterol, and it binds these toxins while they're in your bloodstream causing damage. They don't cause damage. And LDL cholesterol goes up, and your body's protecting yourself from those toxins until your liver has a chance to clear them all out. Until you can eat enough glycogen, you eat enough sugar, that your liver can actually produce enough like beneficial hormones. It can raise metabolism, because that's a signal for your body to raise metabolism, right? Like if you have a lot of extra sugar, right? If you eat ice cream, if you eat a lot of extra sugar, your liver's always filled with glycogen. So that sends a signal, right, to your body based on billions of years of evolution. Like, okay, there's a lot of food out there. So I can run all my systems faster. I don't have to sleep as much, right? I have more energy, right? Like your body temperature goes up. Like I'm sweating right now, and it's not even cold anymore. But I've been drinking coffee, right? And I'm sweating. Like normally most people will not be sweating right now. Here, I'll take my temperature. We'll do an experiment right here. Normal thermometer. Obviously, I haven't been holding it. It's not on, right? You can see it's off. You know, it's just an average thermometer. I bought it on Amazon.com. It's a cheap thermometer. You could probably find the same brand. It's just one of the garbage. What brand is it? I don't even know. Ju-ing. It's probably an Asian brand. I mean, it works fine, but it's just an average thermometer, right? We'll check the rate of my metabolism. You have to take it more than once because it's cold. The first reading is usually not accurate, but we'll see where we're at. And generally, what I was saying is your body uses stored glycogen to manufacture hormones. And it decides to manufacture hormones when there's a surplus. Because that's a signal, okay, there's a lot of food, right? And you see the first reading, we're going to get a higher reading because this we just put in our mouth. We're already 99 degrees. I think you guys can see that, right? 99 degrees Fahrenheit. So now the average person, the average temperature, I linked the article on this in the previous stream, it's actually fallen from 98.6 degrees. It's like 97 degrees now. The average temperature is like 97.8 or something. It's fallen because people eating not enough sugar, too much garbage basically. But basically, when you have a lot of extra sugar, it says to your body, okay, you need to hibernate less, right? You need to be more active, right? You have more energy, right? So it raises metabolism, and the way it raises metabolism, I can't really talk with this thing in my mouth, obviously. We'll have to wait. And I didn't even press the button, but oh well. I pressed it now. Alright, so this is a more accurate reading. Obviously the first one wasn't warmed up. I had it in my mouth, it wasn't on. So this is probably more accurate, and we see this is what I'd expect to be. 99.5 degrees Fahrenheit with normal oil thermometer. Well, you can take your temperature, see how your metabolism is functioning, see how much energy your liver's storing at any given moment. Do you need to eat more food? Do you need to eat more salt? Do you need to drink more coffee? This will let you know. Your temperature, generally, you can tell a lot from it. So that's pretty normal for me. That's my average. Obviously, it's not the average for the human population, because they're not eating the same type of diet that I eat. But basically, what I was saying about the rats is their LDL cholesterol and their triglycerides went up to protect them from the toxins in the rat food, the garbage food they're eating. That's why it went up. And you can look at this independently. You can look up, what does anthrax do to LDL cholesterol? What does bubonic plague do? What does COVID-19 do to LDL cholesterol? Like, that's over the news. Obviously, you probably heard about it. COVID-19 lowers LDL cholesterol. And this is supposed to be a good thing. You need to be prescribed drugs to do this? Obviously not. Your LDL cholesterol is going down. That's not a good thing. And this has been studied in older people. I'll link you guys a study on it, so it's very obvious. All right, so here's a release from ScienceDaily.com. This is a study on PubMed, but this is a link came up. It's a reputable website. I mean, they're not. It's the same thing. It's not like they just come out with random studies, right? It just links there. You can find the full text right there, or it's a story, but it's actually just an article. So I probably shouldn't even link this. Let's just go to source. So it references a journal right down there. So this is like I try not to cite articles, but because it's bad. But I'll cite the journal because that's what you're supposed to do. You can never trust a journalism major on interpreting science. You can't do that. You don't have to take biology to get a major in journalism. You don't have to do that. It's not a requirement. So you cannot trust them to interpret science. They don't do it well. They think epidemiology is a scientific study. That's what they report it as when it's not. It's epidemiology. So, so I linked the study there. It's a full text, and what they found. Okay, it's not the full text. You need to pay for it, and we're not going to do that because this is $90 for 24 hours. Okay, people. Okay, that's they don't want you to read this study, obviously. Charging $90 for it. But ScienceDaily.com, they're pretty reputable. They quoted from the study. So let's see what they quoted from the study, and we'll quote that. So this is what they found, basically. This is the relevant data these people found. This is a quote from the Science Daily article. That's why it's two quotes, because I quoted the quote. If you don't understand how to cite stuff, like you do that sometimes, that's why it's gonna look like that. I've been talking about why sugar's good for you, and so we had some new people. They were curious. So you can see what they found is in older people, right? People who are under more stress, under more risk of disease, the higher their LDL cholesterol, the longer they lived, the less rates, if you go into the data set, you can find it somewhere, the less rates of heart disease, cancer, every disease these people had. Because LDL cholesterol is protective. And that's why old people, once you reach, it's something like 70 years old, like pretty much the higher LDL cholesterol is, the longer you live. And that's what they found. Like, so obviously you don't want to be lowering your cholesterol, taking statins, and that's why, in the experiment where they're testing Coca-Cola raised LDL cholesterol and triglycerides, lowered HDL, which is bad cholesterol. It's they teach you the opposite in medical school. And that's basically why those rats did better. They were able to eat 4 times as much calories. And what I was explaining about hormones is, so they have all this extra glycogen stored. So they don't have to go to sleep, right? Sleeping is basically a shorter version of hibernation. Like animals hibernate because they live in environments where it's cold, right? Where they don't have access to food during the winter. So they've adapted to that environment where they don't get food, they don't get much sunlight. For the winter, they've adapted by hibernating. They basically sleep for not just a night, not just for 5 hours, 6 hours, not for 8 hours, however long you sleep. These bears sleep for a good 2 months, right? That's what they're doing. And they're doing that because in their environment, they lack energy. But we're humans, right? We moved, right, out of tropical environment near the equator, where we evolved, where there's longer days, you can get sunlight 20 hours a day near the equator. Tropical fruit, honey, it's year-round, there's no snow, right? It's a tropical environment. You can get tropical fish, you can get oysters, fish from shallow water, don't have bad fat in them. You can get that year-round. Like, that's where we evolved. That's where we grew bigger brains. And then we traveled to these places like Alaska, right? Where you go pretty north and it can be dark for 22 hours a day during the winter, right? And you only get 2 hours of sunlight. Hard to find sugar, right? The only way is to tap a tree during a certain period and gather maple syrup. It's not easy to do. So obviously they don't have as much sugar. So there, generally what happens is they sleep longer. And in areas where the daylight close to the equator, you don't sleep as much because your metabolism is running at a higher rate. Because you have more energy available in your environment. You have more sunlight, or more light. Yeah, you have more sunlight, basically close to the equator. And you have more fruit. You have more food available for a longer period of time during the day. So basically what happens is when you go to an area where there's no energy available, your body adapts by lowering metabolism. And it does that so that you can survive on a lower amount of calories for a longer period of time, so you can pass off your genes, so the species can survive in an area where there's not enough food. And your body does the opposite thing if you eat more food, right? It's logical, right? If you live in an environment, right, where you're close to the equator, where you're eating food all the time, it's sunny all the time, you have all this extra sugar in your diet, all these extra calories, what your body's going to do is you have all this glycogen stored in your liver, and it's every day. So your body's going to adapt. And it's going to raise the rate that it converts what's called inactive thyroid hormone. It's known as T4 synthetically. Like, you can look it up, it's thyroid hormone, T4. They call it thyroxine. You don't want to take that stuff. It's a pharmaceutical drug. You don't want to take that stuff. But your body basically produces all the T4 it ever needs in your liver. But it doesn't convert it. It only converts it when there's an availability of energy, when you have stored glycogen. And it converts it based on the amount of stored glycogen you have in your liver. Like, that's the basic calculation your body makes on how to adapt its metabolic rate every single day. Like, literally every single day. It's one of the fastest adaptations we have to keep us alive. So the moment there's no food, right? The moment there's nothing to drink, your body immediately makes adaptations. So it immediately lowers metabolism. So you don't dehydrate. So you don't go starving when you don't eat food for a day. Like, your body immediately lowers the amount of energy it expends based on this conversion that happens in your liver directly in response to the amount of sugar stored there at any given moment of the day. This is an ongoing conversion that is only occurring when you have extra sugar stored in your liver. So it doesn't occur if you skip a meal. It doesn't occur if you fast for a week. Like, it doesn't occur if you skip a snack time, basically. Your body downregulates this conversion in real time. And this conversion is you convert inactive thyroid hormone. It's called thyroxine. You convert it into active thyroid hormone, right? It's called, they got different names for it. What's it called? It's basically T3. It's like T4 converts into T3. It's more complex than that. Like, it converts into like T2. Like, there's other things downstream, basically. But thyroid hormone is what controls your metabolic rate. So your body, you have extra sugar, right? You ate extra sugar. It's in your liver. It digested without, you didn't fart, right? You didn't eat some goofy stuff. The bacteria fermented and you couldn't digest it. You just ate ice cream or very clean food, very clean sugar. You drank Coca-Cola like the rats were doing. And what happens is, so your body converts T4 into T3. That speeds up your metabolism. Your temperature goes up, your pulse rate goes up a little bit. And what that does is it doesn't stop there. Now, your body starts converting LDL cholesterol based on the amount of T3 that's already been converted from T4, based on the amount of sugar you currently have at any given moment. Like, right now, this conversion is happening in all of you right now. Your body's adapting based on the last time you ate, how many calories you ate during the day. It's already adapting this second, right? Like, if you're eating, it's converting more. If you're not eating and you haven't eaten in a long enough time, it's already lowering the conversion and into active thyroid hormone. And so when you convert active thyroid hormone and you have extra sugar, your liver also produces LDL cholesterol. It makes the stuff. Like, you make LDL cholesterol, the same stuff that pharmaceutical companies want you to buy their patented drug to lower this thing that you produce when you speed up your metabolism. Like, when you're getting healthier, this is a bad thing. So they sell statins so you can lower it and you can keep your metabolism suppressed. But what happens downstream, right? So you have extra sugar, you're producing LDL cholesterol, you're converting inactive thyroid hormone into active thyroid hormone. This is how your body determines how much testosterone do you make. Is there available energy in your environment for muscle growth? To make stronger muscle, to produce fast twitch muscle? Like, do we have energy for that? Or do we just have energy to maybe just try to maintain the muscle mass we have to survive the famine, right? We don't have energy to grow more advanced muscle tissue, right? More advanced stuff. Like, they don't have the energy to do that if you don't eat enough food. So if you eat enough food and you eat enough sugar, you're making this conversion, you're producing more testosterone. Like, you're producing more of these hormones that are responsible for bone density, for muscle density, for all these things. for hair growth, right? It controls the rate. Obviously, you see it controls your body temperature. It controls your pulse rate. You can measure your pulse rate with it's called a pulse oximeter. You can buy them for like $15 on Amazon.com too. It's just called a pulse oximeter, basically. Just how it sounds is how you spell it. And there's phone apps that test your pulse. They're just not accurate. I've used a bunch of them. They're not accurate at all compared to a pulse oximeter. So I wouldn't even try to measure your pulse with your phone, with the phone camera or whatever. It just doesn't work. But I mean, you could try, but it's not gonna be accurate. But basically, it controls the rate the blood is going through your body, like how fast nutrients and sugar are being, going throughout your body, going into your muscle tissue. Like your muscles store glycogen too. Like how fast sugar and blood is moving through your brain. Like how fast, like all these things are being replenished. Basically, how fast they're being regenerated. Because every day you're taking a huge amount of damage just from all the toxins in our environment. So every day, like this is why people sleep a lot, right? Like if you go and you exercise, right, for the first time in a long time, or you do like a different type of exercise, right, and you do it too much, you spent like an hour at the gym or something, you shouldn't do that. But let's say you did that, and it was a new muscle group you're working for the first time, new exercises. You wake up the next morning, right? You slept a lot longer. You still feel tired. Your muscles are all sore. You're a lot hungrier than you were ordinarily, right? You might feel like you got hit by a bus, maybe. Like, if you did some crazy workout, like way too long, broke down a whole bunch of your muscle fibers. That's what it feels like. And basically, like what happens is how fast you regenerate muscle tissue, how fast you recover and stuff like that is based on your metabolism. It's based on how much sugar you're storing and how much is being converted to all these hormones that correct injury. Like you'll notice, like if you follow professional athletes at all, pretty much, you've heard about some of these guys that are setting records, right? Whatever it is, whatever sport it is, they test positive for steroids, right? At one point or another, right? They break a home run record. Oh, they were on like clenbuterol or something. Like some boxers are on clenbuterol a lot of times. They try to pretend they ate some tainted meat, but you don't test positive on a blood test when you eat tainted meat, even though that's what they tell the fans. So there's one, what's his name? I should remember his name. He's like the top, what's his name? It's embarrassing. I don't remember his name. Canelo Alvarez. Like he tested positive a bunch of times for clenbuterol. Blamed it on tainted meat he was eating in Mexico at training camp, but like there's a reason that he started performing a lot better right after he lost to Mayweather. Like a long time ago, it was like a decade ago probably by now. But he started using steroids. He was probably already using them, but he got older. And this is like if you remember Barry Bonds, Mark McGwire breaking home run records by like huge margins, Sammy Sosa, like they were all on steroids at the time, like different ones. It's super common in the NFL. Like every single linebacker, every single lineman is on something. Like every single one of them. It's like humans don't grow that big naturally. Like it's just not. It don't matter if they're recruiting worldwide. These people, like they mainly come from U.S. colleges. They've always been coming from U.S. colleges, and they've never been this big in history of the sport of football. Like you don't have, like you literally have running backs, tight ends, wide receivers that literally weigh 250 pounds. They run like, they run like a 50-yard or whatever in like 5 seconds, right? This is not, humans can't do that. I mean, they can obviously. When they eat enough sugar, obviously this is human potential, but they're doing this with steroids, right? And so this is how you can see, this is what metabolism controls. Like this is why they get so good at sports. They're not doing it naturally, like they're skipping the steps, and that's why all of these drugs have major side effects. Like a lot of these people get prostate cancer, they get cancers related to their endocrine system, to their hormonal system. Like they get a lot of these diseases because when you supplement too much testosterone, right, even just a little bit, like 1 milligram is only safe like if your temperature is over 99 degrees. Like I wouldn't even touch that stuff because it's just not safe, and there's no reason for it. Like you get way better effect to just eat more sugar and drink more caffeine, basically. Because the problem with these steroids, they're all downstream, right? You're skipping these steps, so you're tricking your metabolism, right? So basically, your metabolism only produces the levels of testosterone and stuff that these guys have when they're eating an absurd amount of calories, right? And they're basically extremely healthy, and they're eating an absurd amount of calories, and then their testosterone level is going to be very high. And occasionally you see this in Olympic athletes. Like you hear stories like Michael Phelps is an example I used before. Like this guy was eating like 10,000 calories of pretty much junk food every day when he was training for the Olympics. He was one of the, if you look at pictures of him from like, I don't remember when it was. It was probably like 2008 Olympics or something like that, 2012, something around then, when he was like one of the best swimmers in the world by like a big margin. And he probably wasn't on steroids because they actually they do very good testing in the Olympics. Like even back then. Like, he probably could have been on something. There's a lot of stuff. Like, I know stuff you could take that's not going to show up on a blood test. And I don't coach people, I don't coach anyone that's performing to beat blood tests, but I know a bunch of stuff that beats blood tests, that could easily beat a blood test on the same day of a fight or something, like right before a urine test. It's not going to show up. These people don't even know what it is. They don't even test for it. It's not even unnatural. Like, your body naturally produces everything that's healthy for you, but it's just like, I'm sure in these communities they're doing stuff that's like, it's not healthy, it's not good for you, but it's easy to beat these tests. Most tests, the Olympic test is hard to beat. So like, there's a better chance that Michael Phelps was more legitimate back then, and he was eating 10,000 calories a day. Like, there's articles about it. He was eating a bunch of pancakes and just junk food like cereal. He was eating like, you can just Google Michael Phelps like diet or whatever. There's a bunch of articles that pop up. I'll link one. Like, here you go. Like here's an article about him from 2008. Like, if you see the title right, here, I'll link it. You can see the title from the link. Like how Olympic swimmers can keep eating such insane quantities of food, right? Don't make no sense to these people. But how can they eat 10,000 calories a day and be like, look like one of the most in shape, like lowest body fat humans that there is, right? This guy's eating 12,000 calories a day. What's he saying? He's eating fried egg sandwiches with a bunch of cheese and stuff. He's drinking 2 cups of coffee, 5 egg omelet, like a bowl of cereal, 3 slices of French toast, and he's eating this is breakfast. So he's eating like 10,000 calories a day. And there's another article about this. Like, this is a recent diet. I linked it before in a forum that I post occasionally, so I can pull it up pretty easily. It's from last year or earlier this year. Here, I'll just link. There's a bunch of them to cover this, but this is just Business Insider. It's just covered by a bunch of things, but basically it's about LeBron James, obviously one of the best players, obviously in the history of basketball. Like, and this guy, like, obviously his teammate, Tristan Thompson, not a good player in the NBA. Pretty much one of the worst role players that you have at the power forward or center position these days. Like, he can't shoot threes really that well at all. Like, he doesn't have a presence, down there. He's not big enough. You don't want him on your team, basically. You don't want to trade for Tristan Thompson. You want to try to get rid of him and take salary back or trade picks back if you have him on your team. Probably one of the most overvalued, like, I don't even know what he's probably listed as a center now, but he's the most overvalued player because he played, with Cleveland when LeBron James was there. But he's terrible. He's a terrible player. Like, but obviously Tristan Thompson is trying to pay attention to what he eats. He's trying to get better, right? Because obviously because he sucks. He's trying to get better, so he's probably eating a lot of vegetables. And this is Tristan Thompson. I'll quote it. It's gonna be too much. But here, I'll quote a shorter thing. It's gonna be too much. You can read the article if you care about Tristan Thompson's full quotes. But this is viewpoint, right? It's the average viewpoint. He has the worst, obviously. You can see the quote. Tristan Thompson doesn't understand. LeBron James eating a ton of calories, just a bunch of junk. He's drowning his French toast in maple syrup, right? And then he's going to practice right after that. He's not. He doesn't get food coming. He doesn't got to sit on the couch. He just goes to practice. And he goes and dunks after eating all this French toast with maple syrup, all these desserts, right? And LeBron James, one of the best in shape players, in the league, like for most of his career. He's always in good shape. And that one time he wasn't in good shape, if you guys remember, he followed the NBA. There was a period, probably, I want to say this was, when was this? I mean, this was recent, but not too recent. It's probably like five years ago, maybe. The Lakers hired a nutritionist that was into like paleo diets, if you've heard of that. Like they avoid sugar, they avoid modern processed foods, refined foods that have been improved by technology. They don't eat them. They only eat natural foods. They avoid sugar. And the Lakers hired this person to be their nutritionist. This was about 5 or 6 years ago. You can probably find when. And so this person changed like the Lakers, basically what they ate, like what they were eating, what they were traveling with, what they were eating before games. And this season, like LeBron James had a terrible season. The Lakers, or LeBron James was not on the Lakers then. Never mind, he was not on the Lakers, so he got saved from this, whatever happened there. But I don't remember who was on the Lakers. They had a terrible season, and a whole bunch of their players got injured that year. Like they had like 5 players get injured, and like they weren't necessarily super serious injuries, but like it was an anomaly. Like it was more injuries than normal that you would get on like a starting five or like players that are playing like in the rotation, like 8 players usually on an average NBA team. And like a whole bunch of them, it was like 4, 5, or 6 of those players in the main rotation got injured that year that they weren't eating enough sugar. And they didn't make the playoffs, I don't think. I think they were very bad that year. I don't think they even made the playoffs. And the Lakers, they usually make the playoffs. Like it was very bad. Like a couple seasons when they had that person, making them avoid sugar. But like you can see the best players, the best athletes, like Usain Bolt's another example. Another guy in the Olympics ate like 50 chicken McNuggets, or I think it was like 100 actually. So here's an article from the 2000. When was this? It's one of the recent Olympics, the Beijing Olympics. I don't really follow the Olympics, so I don't really know when they are, but so here he estimated himself he ate 1,000 McDonald's chicken McNuggets during the Beijing Olympics, or 100 per day over 10 days while he was there. So the best athletes, the people with the lowest body fat percentage rate, the people that look the best, they look the most ripped. They're the best in their country. They're the best in the world, kind of at some of these sports. Obviously, these are finalists, gold medalists in the Olympics. Michael Phelps, like Usain Bolt, like fastest dude in the world. Like Michael Phelps was one of the best swimmers, like fastest swimmer in the world when he was good, when he was in his prime at the Olympics. So like LeBron James, obviously one of the best NBA players in history, and like he's eating obviously a bunch of calories of just French toast and stuff. This is what he's doing every day. Like, and these people, they're obviously not paying attention to what they're eating. Like their metabolism is functioning at such a high rate. They're eating so many calories, like 10,000 calories probably on average, these people that are competing, training at such a high level. Like their liver can actually detoxify a lot of this garbage so that they still function better than every other human, basically, for a period of time. And they're not paying, they're obviously 100 chicken McNuggets, 1,000 chicken McNuggets the whole time you're at the Olympics, getting the gold medal. Like, imagine if he was just drinking Coca-Cola and eating, something that's a bit healthier than chicken McNuggets for his protein source. Like, maybe just drinking some chocolate milk, right? Maybe he was eating some cheeseburgers from McDonald's instead of chicken McNuggets. Getting a bunch of large Cokes with each double cheeseburger, right? Maybe he would have set a record that's even better, probably, than 100 chicken McNuggets a day. Like, all these people, they'd be better if they paid attention to what they eat. But this shows you can just eat a lot of junk food. Like, you don't really want to do that. You're probably not going to have the same results because you're not training like these people. But you kind of should get the concept. It's like there's not an example of a very good athlete that eats salads for every meal. Like, this is not a thing. Like, that drinks water and not Gatorade. Like, you notice during NBA games, during football games, during even boxing, like in between rounds, they're not drinking water. Like it's a different color. It's maybe Gatorade mixed with more electrolytes, more salt probably if they got a good trainer, more sugar in there, something in there. They're probably putting some type of steroid in there too. Like caffeine is common. Like caffeine is very common. Like if you follow the NBA, like Damian Lillard and CJ McCollum are some of the best 3-point shooters in the entire league. They're very good for a very long time at shooting 3-pointers. Like not many players in the league are that consistent at that high percentage for that long a period of time. And especially like Damian Lillard and CJ McCollum are unique because they're in the Western Conference. The Trailblazers have always sucked their entire careers. They're always a bottom seed in the Western Conference. They always make the playoffs. And they shoot these absurd 3-point percentages in the Western Conference as best defenders, like the best playoff teams. And they're shooting higher percentages in the playoffs. Like their percentage is not dropping off. Like Damian Lillard plays better in the playoffs than he does in the regular season. And one of the things the Trailblazers do, one of the things their nutrition, the guy they hired for nutrition, like in the last 5 years, he's still there. What this guy does, their trainer, whatever he is when he started working with them, it was recent. I think it's probably 6-7 years by now he's been there. They didn't drink coffee. It wasn't a thing. Like a lot of these people, they grow up very poor, right? Like they're like LeBron James from the projects, right? They don't necessarily know what coffee is, right? They never tried it before. So this guy, he started making espresso shots before the games. And that's when Damian Lillard and CJ McCollum, they started just being godlike from three, and not just from the normal 3-point line. These players both, like Stephen Curry is like the more public example, but they both have the same range. Like they can shoot it from 40 feet, 45 feet, like at pretty much the same percentage. Like it doesn't really fall off. And the reason they can do this is they're drinking coffee before every game. They're drinking espresso shots before every game. And they've been interviewed about this. And I'll pull up an interview about it. Let me link. I already linked Usain Bolt. Like, I'll pull up an article about this. And this is catching on in the NBA. Like, I guess this is a more recent article from 2019. Like, I remember reading an article about this a long time ago when I was paying a lot more attention to the NBA. Which is not so much the last year, or last 2 years, I haven't been paying as much attention to the NBA. But at one point in time I was. And I read a earlier article about this, and obviously it's catching on because it works. And you can see like they're discovering coffee in the NBA. They're noticing they play better. They have better statistics because the caffeine is raising their metabolism in the short term. These people, obviously in the NBA, you see what LeBron James eat. These people are all in extremely good shape. They're not watching their calorie intake. They're eating whenever they feel like it. They're eating whatever they feel like it. So generally, they're following the cravings. They're eating better than most people. That's why they're in such good shape. And now some of them are adding coffee, and they're figuring out, okay, they perform way better, and they do this. Analytics shows this. Like analytics has taken over the NBA in the last, or not that it hasn't really taken over the NBA, but some teams like the Spurs, like the Warriors, they use a lot more analytics and a lot more statistics kind of than other teams do when they're trying to draft players, and that's why they've kind of been much better teams, recently compared to other teams where it's mainly just some guy that was in the league at one point and now he's the general manager and he really doesn't know what he's doing. He doesn't have an analytics team like most of the NBA does probably at this point, but they really didn't 10 years ago. But in sports betting, like this has been around for a very long time. Like this is just how sports betting is beat, just by large databases, paying attention to analytics. That's how you learn what lines are just not accurate. Like in sports betting, it's based just all on analyzing statistics that are available to everyone that people just don't pay attention to. They're not trying to pay attention to it. They're just watching the game. And generally, the average population is betting on who they think is going to win. They're not paying attention to the line. They're not paying attention to like who Steph Curry is playing. They're just like, Steph Curry makes threes, I'm gonna bet the over on his threes. They're not paying attention, when he's playing like the Clippers and he's been going to be guarded by Patrick Beverley and he's not injured this game, and maybe he was injured the first half of the season. So versus the Clippers, like the line for Steph Curry's threes, right? It's way too high because he was playing against like Austin Rivers or something was defending him, right? But now Patrick Beverley's going to be defending him, so he's not going to shoot that high. The 3-point percentage, you're going to have to bet the under, like in this game. But the line didn't change. The line is just based on the average for the season. It doesn't take that into account. So like that's something that's just obvious just from looking at the matchup, just from understanding who's injured and who's not, and what's been going on throughout the season. But obviously, like it obviously goes way more advanced than that. But this is where first heard about the Trailblazers doing this a while ago, and obviously this article shows about other NBA teams starting to do this. But like here's this is another. They have to have linked this from some earlier article. This might be the one. Yeah, I think this is the article I first read. I'm gonna load this, the ESPN article. Let me see if it's the first one. I'll link it. It's specifically about Trailblazers. So this is a recent article. Like this is obviously there's older articles about this, but let's see. This pretty much covers it. Like so they started this in 2014, and this article goes over the history of it. When they're talking about how their whole team pretty much, I'll just link it's from there. You scroll down, and this is the start of it. Like where they explain it, you can scroll down, you can search this quote, and it just goes to when they started in 2014. Trailblazers started doing this. But pretty much, no one in the NBA did this, like until very recently. They would just drink Gatorade or like Red Bull or something. Maybe if they were probably just Gatorade, or like just whatever, water even. But I mean, you can look that up, and you can look up what they're shooting before 2014, probably before 2015, because that's gonna take some time to have an effect. But you can see, like in professional athletes, this stuff is, this stuff is understood. Like I'll turn my lights on. That's another example. So you can see these are 250-watt lights, and they also activate cellular metabolism. It's one of those things. It's nighttime now. It's dark outside, but I'm still getting the same beneficial spectrum of light from the sun. 750 watts of it. There's three 250-watt lights. So it's 750 watts. It's not as strong as the sun, but it's pretty close to me, right? So this gets me. It's nighttime, but I'm still getting light. I still got sugar, so there's no reason for me to hibernate, right? And when I do go to hibernate, it's generally only for 4 or 5 hours, because my body's adapted its metabolism. It knows, okay, I can sleep for 4 hours, and I can wake up, and there's gonna be food, even though it's still dark. And my body's learned that, so it's adapted its metabolic rate, and that's why when I took my temperature earlier, like before these lights were on, when I had normal light on, windows all open, it's dark outside, my temperature's 99.5 degrees. Like, it could be the highest temperature, like in this entire city, because this San Francisco, it's cold. Like people usually, not a lot of sunlight. Like the only people with higher temperatures than me, they're probably higher because their cortisol's high and they have some disease. They're sick. Their temperature is going up to protect them from a pathogen, from a bacteria they've been exposed to. So your temperature can go up when your stress hormones go up. That's why you get a fever when you're sick. But it also goes up when you're producing more energy and you start expending extra sugar as heat. Like it's pretty much impossible to store extra sugar as fat because it's been studied in humans. And this is another thing I'll link you, because we linked a study about rats, right? They didn't gain weight, but what about humans? We're not rats, right? But it's been studied in humans too. So we're just gonna pull up this. We're gonna pull up this study. So here it is. I just found it because I know what to Google. You're not gonna read this in medical school and nutrition school. You're not gonna find this study, but it's an actual study from the American Journal of Clinical Nutrition. Um, but obviously no one read this study. No, they don't teach you this. But here I'll link it so you guys follow along with what this study says. And then this is probably all I have to go over. Just explain all this. Then I can clip this so I can just pretty much went over everything. But this study, the title is obviously de novo lipogenesis during controlled overfeeding with sucrose or glucose in lean and obese women. So this is different. It's a different study than I was thinking of. I was thinking of one that tested this, I think, in athletes, but we'll see. We'll see what they found in this one. And you'll notice if you're reading the results, the overfeeding group that was eating extra sugar, they had the exact result you would expect if you've been paying attention. Their production, you notice they say estimated amounts of absolute VLDL production. So these people understand your body is producing LDL. And it ranged from 2 grams a day, the control, to a maximum of 10 grams a day for the ones that were overfeeding in sugar. So their extra sugar was causing them to produce more cholesterol, and that's because they were obese women, and these are part of the substance are obese women. They're not they're not healthy. They're gonna have toxins that just probably in their bloodstream. That's probably why the LDL is going up so much. But let me see. So what they concluded in this study, this is not the study I was thinking of, but they had the same conclusion. And I'll go ahead and quote it here, and I'll look for the other study. The other study's better. But what they found, this is even in obese people. So even in people already fat, right? De novo lipogenesis, it didn't contribute to total fat balance after overfeeding. So they're overfeeding people that are already obese with sugar, basically with glucose or sucrose. That's sugar. Like sucrose is half glucose, half fructose. Glucose is just glucose. It's just sugar. Pretty much once it reaches your tongue, you start absorbing it, but it didn't contribute. Like, no, they couldn't conclude anything about de novo lipogenesis, which is fat production from sugar. And this is not the only study that looked at this. I was looking at a different one. Or what the one I was like. There's one I always cite that's a much better done study, and I'm gonna find it. Alright, so I typed the right keywords this time, and I found a study. So here's a study, if you want to follow along, I'm gonna link it right now. And it's got a goofy title, obviously. That's why you know they're actually studying something. This is the title. Glycogen storage capacity and de novo lipogenesis, which means fat creation. De novo lipogenesis, that's your body, human body producing fat, that's what it's called. During massive carbohydrate overfeeding in man. So you know that they did something here. They did a massive overfeeding experiment. They're pretty much trying to see how much carbohydrate do you need to eat in a sitting to actually make your body produce fat. Like, what does it take? So first in this study, you can see from the abstract, this was a somewhat controlled experiment. They depleted they basically managed their diet prior to the study for 3 days. And they pretty much decreased their carbohydrate intake during these 3 days. So they're reducing the amount of carbohydrate that's being stored in their muscles and in their liver. Over a 3-day period, they're still eating carbohydrate, but the diet you can see is 10% carbohydrate. That's a terrible diet, obviously. 75% fat, 15% protein. You don't want to eat a diet like that. You'd rather have the 75% carbohydrate and 10% fat and 15% protein. Then they'd be fine, but yeah. So what they did, and you can see they did this. This was a good study because they did this, I think, twice with both groups. When taking breaks in between, they took the measurements for both groups. Let me see. So basically, they did this study. You can see their methods. It's not the simplest from this abstract. Let me see if the full text is free or not. You can find the full text if you search around enough, but this one, you have to pay $35. We want to buy it, obviously we're not going to do that. We never buy them. But basically, you can see what they found. Like, they found that pretty much you have to consume 500 grams of carbohydrate in a single sitting before you can even measure any increase in de novo lipogenesis, which is fat creation from sugar. It just is not really possible to do. Despite what everyone thinks, you eat sugar, you get fat. It's just not possible. And this experiment kind of shows you why. What happens? It's when glycogen stores are saturated. Massive intakes of carbohydrate are disposed of by high carbohydrate oxidation rates and substantial de novo lipid synthesis without post-absorptive hyperglycemia. So what hyperglycemia is it means that despite eating 2,000 calories of sugar in a single sitting, these are random people. They're not people like me that are used to doing this every single day. These are random people. They're not used to this. Their body's not used to this, right? Their blood sugar didn't become unstable at all. They couldn't, no noticeable thing. They could, nothing happened there. Doesn't matter eating 2,000 calories of sugar in a single sitting. Like, didn't matter. It didn't change their blood sugar. They didn't make fat. Like, pretty much they had to eat 2,000 calories to even measure a tiny amount of fat. And what they noticed is it's mainly being oxidized by high carbohydrate oxidation rates. So their metabolism is increasing substantially. That's what that means. The cells are oxidizing carbohydrate, turning it into basically energy, like expending carbon dioxide, expending, that's what they're doing. And they're not really producing fat from this. Like, it's a very small amount when you go into the data set. Like, you can find the data set somewhere. You can go around for. You can find it in some obscure journal that has it just published there. But this basically what all the studies I listed, they all basically say the same thing. They all explain everything. Like, you saw what the diet soda did to the cholesterol. You saw what the water did. You saw it in one of these other studies I linked. that showed that it was going down. I think it was, where was it? It was up here. Oh, the older people, they have better health outcomes. Pretty much the higher the LDL cholesterol is once they reach old age. So yeah, that was probably a longer answer than you needed. I don't even know if you're still here. Where are you, Cayuse? That's why I don't really believe that sugar is not healthy. That's why I actually try to eat as much sugar as I can every single day. I'm trying to eat more than I did yesterday. Um, but yeah, that was obviously a bit of a long answer.